In this video, we're going to examine some of the characteristics that we look at when we look at functions. And the first most common thing that we look at is domain and range. So we're going to start with domain because without the domain, we would not have any function at all. So the domain is our input values and they are our values of x. So when we look inside our foldable, we see we have a function. And I know it's a function because it passes the vertical line test. As I take my vertical line across a function, it only touches it one place at a time. So I want to find the domain. So the domain are my values of x. I look at my x-axis for my values of x, which means that I'm always going to make sure that my ruler is vertical. And I'm going to find the left boundary, and it's touching my function, and it's going to continue all the way through until I find the right boundary. So initially it looks like my domain might start here at around -3 point something, but that's actually not the case. I have to remember that this function continues, and as it continues, it is not only going up, it is also getting wide. So this keeps getting wider as I draw more and more of my function. So if we look here, I can see that my function, if I can imagine this going up high enough, is actually going to start at an input value of -infinity, and it's going to keep going past this point because my function is going up and it keeps getting wider, so it's going to go all the way to +infinity. So if I were going to state what my domain is for this function, my domain is all real numbers and I could state that in interval notation, which would be I'm going to start at -infinity and go to +infinity. That's what all real numbers are, and you need to remember that this is not a point. Okay, this is not a point. This is actually telling me I'm starting at -infinity and going all the way to +infinity. So for this function, my domain was all real numbers. So we're going to look at the same function, but we're going to talk about range. So domain is my input, so range must be my output values, or I can say it as my values of y. So this is my in, this is my out. You can think of this as my answers on this side. So on this graph, we looked at our values of the x-axis. For my range, I need to look at the values of my y-axis. So my y-axis runs here. So in this case, I'm going to hold my ruler so it's always touching my y-axis. I'm always going to start at the bottom and move my way to the top. So my function, there's no picture of the function here, so my lower bounds can't be there. It has to start right here where y is -9. And my function keeps going. And remember, it doesn't stop here. because this is a quadratic, and I know that this keeps going up. So it keeps going up and it keeps getting wider. But I'm dealing with how tall. So it keeps going forever up. So that means it's going to go to positive infinity. And it's starting right here at -9. So if I'm going to do my range, I'm looking at how tall is the function. So I might ask that question, how tall? And it's from floor to ceiling. Where on this one, with my domain, I was asking how wide is it? So let's write that over here. How wide? And I'm going to look from left to right. So if you keep those things straight, it will help you figure out domain and range on a function. So here my floor is what? My floor is at -9, and I go all the way up to infinity. So here it includes -9. I can never make it to infinity, so I write it like this. This means it includes, this means it just touches. The other way to say this is, well, what's happening to my y values? My y values are getting bigger than -9. So I can say my y values are greater than or equal to -9. These two things mean the same. So now you can see on the same function, this tells me my domain by looking how wide it is, and this tells me my range by telling me how tall it is. So for domain, I look from left to right. I have to imagine what happens to the function as it keeps going in this case. And here, I'm going to look at how tall, where's the floor, and where's the ceiling.